Hi, this is Swathiramya, Assistant Professor, AIDS Department. In this video, we are going to discuss about the process and understanding the process concepts, which comes under the Unit 2 Process Management in Operating System and Virtualization. This topic is very important because every activity performed by the computer system is based on the process. Whether you open a browser, compiling a program, playing music, or even typing in a text editor, the operating system internally creates and manages the process. So, by understanding this topic, you are actually learning how an operating system brings a computer system to life. So, let's go into the slides. Process control. Now let's see the structure of PCB. Before getting into the structure of PCB, let's see why this process control block is so important. Because the operating system handles multiple processes at the same time. It must schedule the process, allocate the CPU, manage the memory, and perform the context switching from one process to the another process, track all the states of the process which is running in the backyard. Without storing all the process information, it is not at all possible. So for every process it has been created, it should have some record or the file. So that is how the PCB is. It has the details of every process. Whenever the process is created, PCB would have been created with that. Without the PCB, the operating system could not be able to run as successful as. So this is a storage, it is a data structure. As I told, it's a data structure maintained by the operator system. Now let us see what informations are stored inside this PCB so that you can able to understand why this PCB is very important. So let us see the structure of PCB. Whenever the process is created, I told PCB will also be created. So starting from its component. So about the next component, that is CPU register. This is also already we discussed in the structure of components of the process. So during the execution, CPU uses registers to store the temporary data. When the context switching, as I told, the CPU will keep on moving from one process to another process. So during this context switching happens, OS needs, but the execution has been done halfly. So this due to this execution, some kind of data has been generated. But this data is also needed to complete the execution, complete the process execution further. This data is needed for the future use also. So, but it is a temporary one. So intermediate one. So this kind of data will be saved in the register, that is in CPU register. See, when the process run again, these values are restored. This will ensure the smooth multitasking one. Okay, so CPU register and program counter is very important when there is a context switching. Moving to the next thing, that is memory management information. Each process needs the memory. Obviously, without the memory, the set of instruction and execution is not at all possible. So PCB stores few details about the base register, limit register, and some kind of paging table. These all concepts will be studied in the later part of operating system. So these will have some basic data about the register, all those things. This will help the OS to manage and protect memory allocated to that process. So this is how the memory management information will be. Then about the input output status information, the process may use the file, or it may use the printer, or it can use different resources. It can use the file, printer, keyboard, or network resource, any kind of resources. So we need the resource, we need the status of input output. Currently what input output resource has been used by the process. PCB stores the input output devices, which input output time has been allocated at what time, and how much resources has been used, and how much input output resources is needed for further execution. All those data will be there in input output status. So it will input output devices are allocated and what process, what operations are pending till what things we have been done already. All those things will be there in input output status. This is how the resource management done. Input output resource management will be done with the help of input output status. Then about the scheduling information. Scheduling is very important concepts. In the next unit we will discuss about the scheduling, different types of scheduling. So this will have what kind of scheduling it has been used there, whether priority scheduling or first come first scheduling, what kind of scheduling has been used, all those informations will be there. The priority of the process has also be there in this scheduling, and the scheduling queue pointers, CPU burst time. The CPU scheduler uses these. See, when the CPU has to make a schedule to execution of particular process, it needs say burst time. How many seconds, milliseconds needed for the execution of this particular process? It needs that time. That time is called burst time. The time it requires to complete the execution. For start to end, how many milliseconds is needed to run this process? It needed that time. That time is called burst time, and it will have the queue pointers. Whenever the process enters, you will have the queue inside the process all will be there in a queue. Based on the scheduling methodology, it will take the process. CPU will take the process and it will execute the process. So we need the queue address, the queue address, that is queue pointer information is also okay. This is how the structure of PCB. From this, I think you can understand from these three videos, you will understand what is process, what is process structure, what all the states of the process, and PCB structure. Thank you.